Man, this is so much work. Man, that took a lot of energy and a lot of time to run up these stairs. Man, that's a lot of power. Wait a sec. You don't even know what that means yet. I'm gonna hand it off to Professor Arnav.
Okay, hi, I'm Professor Arnav, and I'm here to talk to you about work and power. So, Noah mentioned that he was doing work while going up the stairs. What exactly does this mean? Well, work is the transfer of energy through motion. I drew a little diagram. Take a closer look. So, work is done by taking the magnitude of the force times the displacement of the force times the direction that the force is applied in. So, this is a diagram. So, this is the magnitude of the force. The direction in correspondence to the horizon and the displacement are all multiplied to get you your value of work.
Professor Arnav, you just mentioned 3 different things. What unit is work measured in?
Well, Noah, I'm glad you asked. Work is measured in a unit called joules. Joules is 1 Newton meter. This is found by taking your cosine theta times the force, which is measured in newtons, times the displacement, which is measured in meters, to give you with joules.
Wait, Professor,
Yes, Noah?
now that I know that it's measured in joules, when can we see something like this occurring like in real life?
Noah. Well, as we can see here, Noah is pushing this trash can across the floor, which is his displacement, and he's pushing at an angle about 10 degrees up. So let's say that we take this, the force times the displacement times the cosine of his angle, and we get the amount of work he's done. So, as I mentioned in the beginning, work is a change in motion and energy, right? So how do we quantify this in another equation for what equals work? Well, work is equal to the change in energy. That's all it is. It's pretty simple.
Wait, Professor Arnav, now that we've covered work and energy, what the heck is power?
Well, I'm glad you asked what power is. So we know what work is, and we know what energy is. Now, power is basically the change of energy over time. So the change of energy we know is work, and this is a joule, and time we know is seconds. So you may be wondering what unit power is. Well, power is actually measured in watts. 1 watt, measured written in a capital W, is equal to 1 joule per second. It's that simple.
Wow, thank you, Professor Arnav. Can you go over some real life examples now?
Well, I'm glad you asked that, Noah. Let's go over some examples where we'd see power and work in our real life. So, everyone drives a car, right? The car looks like this, has nice wheels, say it's blue, and their car, let's say, is going in this direction along a flat road, so it's not at an angle, right? So the car has amount of force going this way, and it's moving this way because the amount of work applied to it. It also has displacement. Now let's say it covers an X amount of distance within a certain amount of time. So what this leaves us is with an ability to do a power equation. So there's power being applied to this car. So power, as we know, is equal to the change in energy, which is also work, over time, right? So in this instance, the power is the work being done on the car moving this way, which we know because of the displacement and the force, over the amount of time it takes to go over a distance. So this is a really great example that demonstrates work and power being related to each other with the idea of energy.
Wow, thanks, Professor Arnav.